Hey there. Ever wonder how your data stays private while still helping AI get smarter? Today, we're diving into a game-changing approach that's making privacy and accuracy work together. Local Differential Privacy, LDP, meets Conformal Prediction. Let's break it down. So picture this. You're using a health app that predicts your risk of heart disease. But you don't want your medical history exposed. How do you keep your data safe and trust the app's predictions? That's where Local Differential Privacy comes in. It's like a digital privacy mask. Your data gets scrambled with random noise before it leaves your device. Even the app can't see the real thing. But here's the catch. If we scramble data, how does the AI still make reliable predictions? That's where Conformal Prediction steps in. Think of it as a safety net for AI. Instead of just saying, this is the answer, it gives a list of possible answers with a confidence level. For example, I'm 95% sure it's condition A, 3% sure it's B, and 2% sure it's C. The real answer is almost always in that list. Now the big question, how do we keep data private and maintain that confidence? Enter LDP-CP-L and LDP-CP-S, two clever methods from a recent study. Let's unpack them. LDP-CP-L is like a privacy-first shortcut. Here's how it works. 1. You take your sensitive label, e.g., I have diabetes, and add random noise to it, like flipping a coin to decide your answer in a survey. 2. This noisy label is sent to the AI, which uses a special algorithm to adjust for the added randomness. It's great for situations where users have limited computing power, like on a smartphone. But there's a trade-off. The more labels there are like different diseases, the harder it is to keep accuracy high. Then there's LDP-CP-S, which takes privacy further. Instead of scrambling labels, users add noise to their own confidence scores, like how sure they are the AI's prediction is right. This way, even the AI doesn't see the real scores. It's like giving each user a secret code to protect their data, perfect for super-sensitive scenarios like medical imaging. But here's the kicker. Both methods still guarantee the AI's predictions are reliable. In tests on medical datasets, they matched non-private systems almost perfectly, even with strong privacy settings. The researchers also introduced the shuffle model, where data is mixed anonymously before reaching the AI. It's like a secret box that scrambles messages, making privacy even stronger without sacrificing accuracy. So why does this matter? Imagine using a language model without your queries being stored, or getting a diagnosis without your records leaking. This tech is bridging the gap between privacy and performance, making AI safer for everyone. Thanks for watching. If you want to explore how privacy and accuracy can coexist, hit subscribe for more deep dives into the science behind the tech. Until next time, stay curious. Ever wondered how AI is changing healthcare? Let's break it down. Imagine a world where doctors have a superpowered assistant, someone who can spot tiny changes in a scan or predict risks before symptoms appear. That's the promise of medical AI, and projects like MedMNIST are making it a reality. Here's the thing. AI needs data to learn, but medical data is often locked away in hospitals or private labs. MedMNIST changes that by creating a shared library of medical images. Think of it as a recipe book for AI, where researchers worldwide can test and improve their algorithms. This isn't just about fancy tech, it's about saving lives. When AI gets better at spotting diseases like cancer or heart conditions early, treatments become more effective. And when these tools are open source, they don't just stay in elite labs, they spread to clinics in developing countries, giving more people access to cutting-edge care. So next time you hear about AI in healthcare, remember, it's not just about robots replacing doctors. It's about equipping them with smarter tools, faster breakthroughs, and a future where innovation isn't a privilege, it's a global gift. Stay curious, and let's keep exploring how science is reshaping our world.